So we continue a little bit on nodal. Okay. Okay. If the node, okay, the voltage source is between this. Okay. If the voltage source is between two node, okay, instead of goes to the ground, so make sure you look at the direction of the current. Okay. So if you look here, okay, so start with V2. Start with V2, and then end it with start with V3 and end it V2. Okay, so V3 minus V2. Okay, start, end. Okay, and don't forget it minus. Then also for the voltage source, because it goes to negative, okay, goes into negative, so it will become positive. Okay, so divide by 220. So you have to know how to use this. Okay. And then also another example, this is called a supernode. Okay, supernode means that there is no resistance. Okay, if you look here, there is no resistance. Okay, there is no resistance, and the voltage is directly connected from ground to V1. So what is this mean is that V1 is just equal to 30. No other method. Okay, no other step. It's just V1 automatically goes to 30. So you have to remember this. Okay, these two. So this is called supernode. Okay. Now we continue with mesh analysis or loop analysis. Okay, in nodal analysis, you use node and Kirchhoff current law, but in mesh, you use loop and Kirchhoff voltage law. So this one also, you have to use simultaneous equation. Okay. So this is example problem. Okay, determine the Kirchhoff KCL for each of these mesh. So how to do this? So first thing you have to do, you have to assign the loop. Okay, you have to assign the loop current. This one is called loop current. Okay, this is called a loop current. Okay, remember what I showed you before? This is loop current. Okay. Okay. So this is the loop current and this is branch current. Okay. So so branch current is at the branch. Okay. This is branch current. Okay. So this one for loop current, it use I1, I2, I3. For branch current, don't use the same notation. So for example, this one is IA, IB, IC, ID. So you have to make sure don't use the same notation. So that is how, this is what you have to do first. Okay, let me delete this. So how to do nodal analysis? Okay, first, okay, if you look here, okay, so just put the value first, 12. So V2 is 6, R1 is 3, okay, R2 is 8, R3 is 6, and R4 is 4. So what to do first? When you do nodal mesh analysis or loop analysis, Okay, what to do first is, okay, apply KCL, KVL at I1. Okay, this is the second step actually. The first step is to apply, to assign loop current or mesh current. Okay, so the second step is, okay, the first step usually will be given, but if it's not given in the question, you have to assign yourself. But if already given, don't assign yourself. Okay, you just follow the sign given. Okay, then the next is apply KVL at loop. Okay, we first start with loop 1. So if you look here, it touch negative. Okay, if you look here, when you do loop here, okay, it touch negative. So negative V1. Okay, then goes to here. Okay, so remember that plus R1. Okay, I1 minus I3. Okay, what is this mean? That, okay, because you analyze is analysis done is at loop 1, I1, so you put I1 first. Okay, you put I1 first. Okay, okay, then because it is meet with I3, so you have to minus I3. Okay, that is how you do nodal analysis, mesh analysis. So next you meet R2. So plus R2. Okay, make sure that for resistance always positive. Positive, positive. Make sure always positive. So R2 again, I1 because we doing I1 loop. So I1 minus I2 because it is between I1 and I2. So I1 minus I2. Then equals to 0. So you apply KVL at I1. Then you have to make in the standard form. For nodal analysis, the standard form for unknown is voltage. But for mesh analysis, the standard form for the unknown is current. So for this case is R1 I1, okay, minus. So if you look here, so R1 plus R2 I1, okay, minus R2 I2 minus R3 I3 equals to V1. You have to rearrange so that the unknown is I1, I2, and I3. So just insert the value. Okay, you can insert the value before or after. For you will get the same answer. For this case, R1 plus R2. R1 is 3, R2 is 8. So 8, 11, I1 minus R2 is 8, I2 minus R3 is, wait. I think something wrong, right? This one is not R3, this one is R1. Okay, R1, okay, minus R1 is minus 3, I3 equals to negative or positive V1. V1 is 12. So you get the first simultaneous equation. Okay. So next, apply. Okay. So we apply KVL, PPLY, KVL at I2. So if you apply here, okay, if you apply this, so start with this, okay, R2, I2 minus I1. Okay, remember you doing look at I2, so start with I2, then because the opposite is I1, so use I1 minus I1. Then same with here, plus, always plus for resistance, plus R3, okay, plus R3, I2 minus I3, okay. Then lastly, okay, because the loop, okay, goes to negative, so minus V2 equals to 0. So if you rearrange this, you get R2 plus R3, okay, R2 plus R3, R2 plus R3 minus, oh, so negative R2 I1 plus R2 plus R3 I2 minus R3 I3 equals to V2. So you can insert the value. You can insert before, no problem. Okay. So negative R2 is 8, negative 8 I1 plus R2 and R3 is 8, 6, 14 I2 minus 6 I3 equals to V2 is 6. Okay. So you get the second loop. Next, so next apply KVL at I3. So also the same. Okay, for this case is, okay, start with this, okay, plus, okay, R1 I3 minus I1 plus R4 I3. Okay, for this case, okay, there is no other loop intersect. So because there is no intersection of loop, you just place I3. Only the intersection you have to consider both. Okay, then plus this one have intersection, so R3 I3 minus I2 equals to 0. So rearrange it. Okay, don't forget to rearrange everything. So I1 is negative R3 I1 minus negative R3 I2 plus, okay, R1 plus R3 plus R4 I3 equals to 0. Okay. So yes, insert the value. So R3 is negative 6 I1 minus R3 is 6 I2 plus 3, 6, 9, 13 I3. Okay, 0. So you get the third simultaneous equation. Okay, for second, this one is second, right? second. Okay. And this one is the first. So try to solve this. From this, you will get I1, I2, I3. So try use your calculator to get the answer.
Doctor, you have
Yes.
write the wrong resistor.
Which one?
The last one for the I1 is negative R1 I1.
Negative R1, I1. Okay, wait. Oh, last one, R1. Oh, yes.
Yes.
So this one is I1, right? So
Yes.
this one is 3. Okay. Thank you. So use your calculator. Practice with your calculator. So what is the answer? So what is I1? Anybody can tell me?
6.9.
Okay, 6.9 ampere. This one is
6.3.
6.3 ampere. And last one is
4.5.
4.5.
okay, 4.5 ampere. So all of this is called loop current. Okay, this is just a loop current. Okay, if you look here, only the loop current. Okay, assume that I want to find the current at, for example, here. Okay, as I place is IA. So what is IA? So how to get IA? So how to do this is IA is basically I2 minus I1. Okay, I3. Okay, because IA direction is this way. Okay, the direction goes to the right. So you have to look at the loop that goes to the right. So I2 goes to the right, I2, and I3 goes to the left. So because it goes to the opposite side, you have to put negative 3. Okay, that is for I2. Okay, how about IB? Okay, IB. Okay, IB. If you look here, IB is the opposite direction of the I3. So negative I3. So that is how you get the current. So the value, you just insert the value you get from this. Okay. So I2, IA is basically I2 minus I3, 6.3 minus 4.5. So you get 2.1 point something, right? So 6.3 minus 4.5. You get 1.8 ampere. Okay, equals to 1.8 ampere. For I3 is negative 4.5. So that is how you get the current, the branch current. How to get the voltage? You just apply it. Okay, you get the current, then you use Ohm's law to get the voltage. Okay, can you understand how to get the branch current? Okay, no problem.
I understand.
Yes, I cannot hear you. Okay, no question. Okay, I think yeah, they give you the solution. Okay. So this one is another example. So I give you another example here. So for this case, they don't give any loop current, okay, mesh current. So you have to assign yourself. So assign, okay, I1 and I2. Actually, you can assign any direction, but for this class, I suggest you use clockwise and start with left top, okay? Left top I1, then I2. You can do either way, but it is easier for me to check, okay? Different sign of the loop current will give different answer, but at the end, the answer is the same. Only the step is different. So how to solve this? Okay, same. Okay, assign the loop current first, then I1 apply KVL at I1. So it means negative. So negative V1, okay, plus R1 I1, okay, plus V2 because it's mid at positive. So plus V2 and plus R2 I1 minus I2 equals to 0. So rearrange this. You get R1 plus R2 I1, okay, minus R2 I2 equals to, okay, V1 minus V2. So you get the first simultaneous equation. Is there any value? Okay. Value. So for the value here, okay. So for value, V1 is 10, V2 is 9. 10, 9, and V3 is 1. 5, 10, 5, 5. 5, 10, 5, 5. So 5, 10, 5, 5. So just insert the value. Okay, R2 is 15. Okay, 15 I1 minus R2 is 10. I2 equals to V1 minus V2 is 1. Okay, you get the first simultaneous equation. Then for second simultaneous equation, apply KVL at I2. So when you apply KVL at I2, okay, so start with the top first. You can start either way. You get the same answer. R3 I2 plus V3 plus R4 I2 plus R2 I2 minus I1. Okay, minus V2. Okay, minus because it means minus. Okay, R2 is between I2 and I1. So equals to 0. Then simplify this. So I1 is okay, R1 negative negative R2 I1 plus R2 plus R3 plus R4 I2 equals to V2 minus V3. Okay. Let me know if I don't rearrange it correctly. Okay. So R2 is negative 10 I1 plus R2, R3, R4. So 20. Correct? Okay. 20 I2 equals to V2 minus V3 is 8. V2 minus V3 is 8. Okay. So you get second simultaneous equation. So what is I1 and what is I2? Use your calculator. Okay, use your calculator to get I1 and I2. Don't forget to clear first. So what is the answer?
0.5.
0.5, okay, ampere and
0.65 ampere.
0.65 ampere. So you get the loop current. Okay, how about branch current? Okay, for example, what is the current? Okay, here. Okay, IA. Okay, IA. So what is IA? So IA is basically I, because it goes to up direction, is follow I2. So I2 minus I1. Okay, because it goes up. So you have to follow the loop current that goes up first and then the opposite one. So IA is 0.5 minus 0.65. So you get 0.15 negative ampere. So basically the direction is actually at the opposite. Okay, how to get the current? Okay, we look at another example. Okay. So we look at the last example. Okay, if you look here, there are current source. So when there are current source in mesh analysis, it's called super mesh. Okay. In nodal, it's called super node. If the voltage source present in the only voltage source present in the node, okay, in between node, it's called super node. Okay, for nodal analysis, if the current source present, it is called a super mesh. Okay, this is super mesh. Wait. Okay, super mesh. So how to solve this? First, of course, you have to do loop. So I1, I2, I3. So after you apply loop current, so apply. So for this case, I1 super mesh is located at I1. So automatically I1 equals to I. Okay, assume this is IS. Okay, IS. Okay, it will follow. So IS mean I source. Okay. If you have this condition, you have just to follow it. Okay. If the super mesh is at center, that is a different story. So that one is out of your syllabus. But if the super mesh is at the outside of the mesh, doesn't interact with other mesh, other mesh. Okay. So that one is just I1 will become IS. Then apply KVL at L2. L1 you just ignore because it has super mesh. So apply KVL at I2. So as usual, R2, okay, R2, I2 minus I1 plus R3, I2 minus I3. Okay, then plus because it meet plus. The I2 meet plus, so plus V2 equals to 0. So, okay, R2 I1 negative I2 R1 minus R2 plus R3 I2, okay, this plus minus R3 I3 equals to negative V2. Okay, so you solve this. So insert the value. So R1 is, so I just put it easier. Okay, R2 is I is 0.5 ampere. Okay, this one is 0.5. Okay, because this is in the same direction. If the opposite direction, you have to put negative for super mesh. Okay, 0.5. V2 is 6 volt. Okay, R1 is 3. R2 is 8. R3 is 6. R4 is 4. So just insert the value. So R2 is 8. Okay, negative 8. I1 plus R2 and R3 is 6. 14. I2 minus minus R3. R3 is 6. I3 equals to negative V2 6. Negative 6. Okay, remember that you already obtained the super mesh is I1 is 0.5. You just insert the value in I1. So no need to complicate the equation. So you just negative 8, 0.5. Okay, be careful. If opposite direction, you put negative. So plus 14 I2 minus 6 I3 equals to negative 6. So simplify this. So after this, so 14 I2 minus 6, okay, 6 I3 equals to negative 6 plus 4, negative 2. This is the first simultaneous equation. Okay, then okay, you do the third loop. Okay, for the third loop, okay. So apply KVL at I3. Okay. So apply KVL at I3. Okay, same as before. So R1. So R1 I3 minus I2 I1 minus plus R4 I3 plus R3 I3 minus I2 equals to 0. Okay, just apply the previous method. So then rearrange it. Negative R1 I1 minus negative R3 I3 plus R1 plus R3 plus R4 I3 to 0. Okay, this one is I2. Okay, this one is I2. So same as before, I2 already have value. So negative 3. Okay, negative 3, 0.5 minus R3 is 6 I2 plus R1, R3, R4. 3, 6, 4, 13. Okay, 13 I3 equals to 0. So get this, simplify this. So negative 6 I2 plus 13 I3 equals to 1.5. So this is the second simultaneous equation. So use your calculator to get the answer. The first and the second. So don't do manual because you cannot don't have enough time to do manual simultaneous equation, and you will not given mark to do the manual simultaneous equation. So just use your calculator. So you what is the answer? Don't forget to clear your calculator first to get to insert the value. So what is I2? Already got the answer? Is anybody get the answer?
I2 negative 0.12.
0.12. And I2 is I3 is
0.06.
0.06. Okay. So you get the node. Okay. The node and the mesh current. So if the question asks the branch current, you have to use the method I showed before. Okay. That's it for Kirchhoff current law. The nodal analysis. Is there any more question?
Doctor,
Okay. Yeah.
for the apply KVL at I2,
Via I2, which one?
I2 one, I2 that
This one. Okay, I2.
yeah. Why it meet at the positive, but we put positive also at the voltage 6 voltage 6 watt.
This one. For
V2.
okay, for V2. Okay.
We may have the positive, we should put a negative 6 word, right?
No. If we do loop here, okay.
Oh.
I2 like this. Okay. If mid positive, it is positive. Okay. If mid negative is negative.
Oh,
Okay.
so only for the branch need to
Only for nodal analysis, it's flip.
for
Okay. For mesh analysis, you have to follow. Only for nodal analysis, you have to flip it.
Okay, thank you, Tata.
Okay, welcome. So be careful, eh? Okay, any more question? The attendance, the system down, so I cannot take it anymore. Okay.
Hello, doctor. So only for node analysis, yeah, that is flip.
This one is mesh analysis.
Okay. No, I mean the voltage one, like.
Yeah. Just follow it. If it meet, wait. If meet positive, you have to make sure it positive. Only for nodal analysis, you have to flip it.
Okay, doctor. Thank you.
Okay, welcome.
Doctor.
Yes.
Can I ask? Because I'm doing the question by flipping the I2, like in another direction.
Okay, if another direction, okay.
Yeah, but I still get the same answer. Is it acceptable?
Actually, you should not get the same answer if your the voltage is flipped.
No, I mean the I2. The direction. My direction is the other way around, but I changed the sign in the equation of my equation.
Oh, the I2 is counterclockwise.
Yeah.
Oh yeah, you will get the same answer.
Okay.
Okay,
So
if
it's
you
acceptable, right?
yeah, acceptable. If for example the current is like this, right? I2.
Yeah.
Okay, and the voltage source is plus minus. So the current is V2. Okay, negative V2. Okay.
Okay.
Because it meet negative first. So you have to follow.
Okay.
I just suggest you use counterclockwise because it's easier for me to mark. Because if you use counterclockwise, okay, if you use counterclockwise, I need to create another answer sheet. But if you just do apply clockwise, it's easier for me because all the answers are usually in clockwise.
Okay, doctor.
Okay.
Thank you, doctor.
Welcome. Okay, this is rare, but sometimes happen. Okay. Some question use multiple direction of the loop. Okay, some use like this. Okay, then it different direction. Okay. So for this question is rare, but sometimes they ask is you have to follow the direction. Okay, if the question give like this, but usually at the same direction. Okay, any more question? I think that's all from chapter 1. Okay. Oh, there is a last example. Okay. You want to look at this or not? Because I don't have enough time to show everything, but you can try this. Okay, you can try this. Try to solve this. Okay. Okay, for test 1, it will cover until here. Okay. It will cover until chapter 1. This one is complete chapter 1. Okay, any more question before we end the class? Okay, if there is no question, okay, we end the class. Okay, thank you.
Thank you, doctor.
Thank
Thank
you.
you.
Doctor.
Okay.
Thank you, doctor.
Welcome.
Thank you, doctor.
Thank you very
Thank
much,
you,
doctor.
doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.